when people Google cryotherapy, they're probably going to see a nitrogen cryotherapy chamber. You'll see the head sticking out of this black tube, and you see the gas, right? You see the gas flying out of it. And that white vapor is actually liquid nitrogen vapor. Okay, so that's the evaporated form of liquid nitrogen getting pumped into that system. With the electrically cooled systems, essentially that nitrogen is administered, and that's where they're getting the cooling effect on the skin. The issues with liquid nitrogen, though, is it's an open container. It's still open to the environment. You're still obeying the law of gas laws, right? Cold's going to sink, and then heat's going to rise, right? There's a discrepancy of temperature, and it's not uncommon for individuals actually in the liquid nitrogen tanks to feel a discrepancy. Their legs feel way colder than their upper body. There's an issue with that, though, as it pertains to activating the central nervous system. You have so many thermal receptors in your chest, in your shoulders, your neck, in your head, and your face. Those are the receptors that are going to respond more to thermal regulation than, say, in your calves or your thighs or your hamstrings, right? So with the electrically cooled system, we're not using any nitrogen, no chemicals, which means we can safely breathe the air inside. We actually go into, think of it kind of like in your head right now, imagine a sauna, right? We're in this closed box, right? And that closed box is pumping in air that's electrically cooled down to about negative 170 degrees. You can breathe that air, and you're getting exposed to that air with your shoulders, your head, your neck, and your face. More importantly, there's no two different gases in that system. It's no longer a mixture of gases. It's actually a solution of gases. It's completely uniform from the ground all the way up to the ceiling. So you're going to feel just as cold at your head, neck, and face as you are at your calves and your ankles and your knees. So we have a more potent stimulus to the central nervous system, and that's actually backed by clinical research that electrically cooled whole body cryo, whole body, not partial body, whole body cryo is eliciting about a 20% greater response of norepinephrine released from the central nervous system, indicating a more potent stimulus. Science of cryotherapy, it comes down to direct skin temperature drop. Okay, so we're talking about surface skin temperature, not core body temperature. That's a huge point we have to make initially. We're not dropping core body temperature. We're dropping surface skin temperature. So we go in to negative 170 degrees Fahrenheit for roughly 2.5 minutes is about the first time for everybody. And in that duration, your skin temperature rapidly decreases by 30 to 45 degrees. And if we achieve that specific drop of 30 to 45 degrees, we 100% activate the central nervous system and engage what's called the fight or flight response. Essentially, when that happens, blood vessels constrict on a whole body scale. It starts pushing blood all the way back up into your torso to preserve vital organs. In that process, it's detoxified in the liver. It's enriched with oxygen and nutrients. Okay, but more importantly, you're squeezing those blood vessels, reducing inflammation and swelling systemically, not just in a localized spot. Systemically, we're reducing inflammation. In that duration, you're releasing powerful endorphins. Your body goes into this fight response. It's fighting off the cold, and it wants to release things like dopamine, serotonin, norepinephrine, things that ultimately balance the mood. So from a scientific standpoint, we are much more concerned with surface skin temperature drop than core body temperature. And that's where we're seeing the clinically proven results of reducing pain and inflammation on a whole body scale, alleviating muscle soreness, enhancing athletic performance, in addition to reducing stress levels, improving sleep, and increasing energy.